The notes for Unit 6, Lesson 3 will cover gas variables. So after these set of notes, you will be able to describe the relationship between pressure, volume, and temperature of a gas. So make sure you have your Unit 6 notes packet or a notebook available so you can jot down these notes. All right, so remember a few days ago we had talked about and compared the properties of solids, liquids, and gases. Now we are strictly talking about gases. So these are 4 variables that will affect a gas. One is volume, a second is pressure, a third is temperature, and the 4th factor is a number of moles, which is going to be the amount of gas and the number of particles that you have. So again, now from here on out with our calculations, we are only talking about gas molecules and how they behave with these different variables. All right, so I included some visuals here so you could have a better picture of what the molecules are doing. But the first question is going to compare amount of gas and pressure. So how does the amount of gas affect the pressure? So remember, pressure is the force at which these molecules are colliding with the sides of the container. So if you have more gas molecules, you are going to have more pressure. So that's the general relationship. The why is because when you increase the number of particles, so you look here at this container, there are a ton more particles, and so they're going to be colliding more, which means they're going to be hitting the sides of the container with more force. So if you look at our pressure gauge from one to the next, the pressure gauge is moving in a clockwise direction. And so the pressure is increasing as you increase the number of particles. It would be like if we had 4 students in the room and they were blindfolded and we asked them to walk around. You might bump into somebody, but you might not a ton of collisions. But if we had 38 people in the class that were blindfolded and we asked you to walk around, you'd probably bump into a few more people. So the more particles you have, the more pressure is going to be exerted on the sides of the container. The second relationship we're going to talk about is volume and pressure. So how does a change in volume affect the pressure? So remember, volume is the size of the container. So in this first example, we have a really small container. So if you, increase the volume, so if we go from the first container to the second container, the container is getting bigger, which is going to give you a decrease in pressure. And the reason why is because when you have a bigger space, there's going to be fewer collisions. Same thing like if we increased the size of the hallway, then you wouldn't be bumping into as many students during passing time. But if we, pushed the hallway into a much smaller space, there's going to be more collisions. So if we increase the size of the container, you're going to have fewer collisions, which then is going to result in less pressure or lower pressure. All right, temperature and pressure is the next relationship. So how does a change in temperature affect the pressure? So if you increase the temperature, you will then have an increase in pressure. So the Y, in terms of particle movement, if you increase the temperature, those molecules are going to be moving around faster. Faster moving particles means more collisions and more forceful collisions, so that is going to result in a greater pressure reading. All right, so in your notes, you have this little chart. So this is what we'll use for the relationships, the equation, and showing a graphical analysis of the relationship. So there are 3 laws that we will calculate: Boyle's law, Charles' law, and Guy-Lussac's law. You do not have to remember which name goes with which law, but you do have to remember how pressure and volume are related or how temperature and pressure are related. So Boyle's law is stating that when you increase the volume, you will have a decrease in pressure and vice versa. So if you increase the volume, if there's a greater space for those particles to move around, there's going to be less pressure. So the equation, because we're relating volume and pressure, is P1 times V1 is equal to P2 times V2. So P1 is your first pressure reading. V1 is at a specific volume. And then when you change the volume, the pressure is also going to change. So P2, V2 would be your second pressure reading at a second volume. And so we know, because as volume goes up, pressure goes down, that is an inverse relationship. So here's volume, here's pressure. So our graph is going to kind of look like a curve like that with pressure and volume, because they are, it has an inverse relationship. So as one goes up, the other goes down. Charles' law relates volume and temperature. So when you increase the temperature, those particles are going to move around, they're going to spread out. So if it's in a container that is able to expand, it will also increase the volume. So as you increase the temperature, you increase the volume. So the equation for Charles' law is V1 over T1 is equal to V2 over T2. And then I'm going to have you add a little note. Temperature must be in Kelvin. So the temperature must be in the Kelvin scale when you do this calculation. And then since temperature goes up and volume goes up, it's going to be a direct relationship. So here is temperature and volume, and the graph will look something like this. All right, Guy-Lussac's law relates pressure and temperature. So as you increase the temperature, now this would be assuming that volume stays constant. So if you increase the temperature of something that is a container that cannot expand or contract, then the pressure is going to increase as well. So as you increase the temperature, you're going to increase the pressure. Since this is also a direct relationship, our equation is P1 over T1 is equal to P2 over T2. So again, pressure reading and temperature reading. Temperature, again, must be in Kelvin. Whoops. Yikes, my pen is kind of cutting out here. So temperature must be in Kelvin. And remember, to add or to change Celsius to Kelvin, you add 273. And then since this is a direct relationship, the graph will look similar to Charles' law. So these are the three equations that we'll use to start off. We'll add two other equations to the mix when we, or as the week progresses, but these are the three that we'll start with. Here is the information in a little bit of a neater and nicer typed version if you need to pause the video to add any information that you may have forgotten or missed out on. Okay, last but not least, these are some units that you will see volume, pressure, and temperature in. So just so you can, when you're reading a problem, you can recognize, oh, it's this number is in liters, so liters represents a volume. So volume will be measured in either liters or milliliters. I don't know if it will occur, but volume will also sometimes be in centimeters cubed. That's another volume reading. Pressure will either be in kPa or ATM or mmHg, which is millimeters of mercury. And then temperature from the problem will either be in Celsius or Kelvin, but remember, when you do any calculations, the temperature has to be in that Kelvin scale. So Kelvin, the Kelvin scale does not have negative values. So when you're trying to figure out what would the volume be at a certain temperature, you can't have a negative volume, so we can't use a negative temperature reading. So we always have to convert the temperature to Kelvin when we're doing these calculations. All right, so that is it for the lesson 3 notes. Today we'll do a lot more practice with calculations and understanding how those variables work.